Cloud recording. Right. So thank you for people joining us today for our human-centered AI seminar. Just to give a bit of context, the human-centered AI lab is a cross department group of people just interested in general in human-centered AI. And it's my pleasure today to introduce our speaker, Dr. Greg Adamson, who is an honorary associate professor at the University of Melbourne as part of the School of Population and Global Health. He also was an editor on the IEEE document on ethics and AI, ethically aligned design, and is the technical activities vice president to the IEEE Society on Social Impact of Technology, as well as being a leading expert on the work of Norbert Wiener, who's founder of Cybernetics, and in his day job, he's a cybersecurity practitioner in the transport industry. And Greg is today speaking to us about the question of whether it matters if we can't explain AI. So thank you very much for being here, Greg, and please feel free to take it away.
Okay, well, look, thanks very much for the opportunity to speak to you. I'd like to, so I have been working in the area of explainable AI for a little while, and I address this primarily from a philosophy of technology perspective. So I've just brought up, this is the only slide I've got. I don't want to, things get very complicated very quickly, which provides no value to the discussion at all. So what I want to do is give a high-level introduction to this issue, and then invite questions and spend at least half of the time following the subject through questions and hopefully discussion. So now my background's a little bit mixed. I started off in engineering, and then I moved sideways into information science, and then added e-business and finally law. So I have a few different qualifications. This is helpful in hearing the challenges of explainable AI, because in the explainable AI space, by and large, technologists don't talk to engineers, don't talk to, so information technologists don't talk to engineers, don't talk to lawyers, and don't talk to business people, or practitioners in particular don't talk to doctors. And so the whole thing becomes quite an interesting area where there's an enormous amount of confusion bred. So to begin with, explainable AI. What is explainable AI? Now, some people claim that the discussion of explainable AI goes back many decades, and I love to find the historical roots of events, but I think in this case they're being a little bit they're misleading, and sometimes they're deliberately misleading. The explainable AI field emerged in 2016, and it emerged for a very simple reason, that DARPA announced they were going to have an enormous transforming discussion of AI and explain it through the lens of explainability. So they launched this thing in the same way that they'd previously launched things like figuring out how to develop an autonomous vehicle. And it was launched in 2016. And in the following 3 years, or 3 or 4 years, there were tens of thousands of research papers published on the topic. I find this astounding, that from nothing, you can suddenly have tens of thousands of research papers. The vast majority of these are of poor quality and lack creativity. But nevertheless, with DARPA funding available, everybody who wants to grab a piece of the money will write a paper. That's my skeptical side. So the purpose for DARPA was very clear, and this is, I think this is an important feature. DARPA wanted to understand how they could give warfighters confidence in the decisions provided to them by AI devices. So basically, if you're fighting a war, if you're a soldier or have some other part in fighting a war, and you've got a device and you can say, okay, go and make a decision here and kill somebody. If you feel that the device can't explain why it just blew up a wedding party or killed an innocent person or something like that, then you're going to feel morally concerned about using this dubious weapon, which all you can tell is that it kills people. You can't tell whether it's doing it for any particular reason. And so DARPA wanted to have a reason to believe, that the reason to believe is my term. DARPA wanted to have a reason to have confidence that the people that they were killing with these weapons were people who deserved to be killed, or at least people for whom there was an honest mistake. It looked like a band of terrorists, even if it was a wedding party. Now, they initiated this thing, and within this proposal, they included a very strange, what I find a very strange and dubious assertion, which is that it was okay. You didn't actually have to explain exactly what had happened. All you had to do was give a feasible description of what might have happened. And this takes on the, this is where the concept of post-hoc reasoning comes in. And I'll talk about that in a sec. But firstly, I wanted to talk a little bit about explain. And this is a very strange discussion here. Technologists in general have a very poor understanding of human behavior. In fact, technologists in general have a very poor understanding of the need to understand human behavior. And so if somebody writes a paper such as Tim Miller, very nice paper, saying we should learn something from the social sciences in understanding what it means to explain, he doesn't have to dig very deeply in order for people to say, oh, this is a very authoritative paper which addresses all the questions related to the social sciences and explanation. Whereas all he said was, we've got to realize that just because you tell someone doesn't mean that they get the same message. So his message is very, very simple, but given the very, very low standard of understanding within the technology community, it was a bit of it's been dealt with as a outstanding and important breakthrough. And I like Tim. I used to work beside him. This is not a criticism of Tim, it's a criticism of the way his work is used as a blanket assumption that every possible concern of the humanities has been addressed in the way explainable AI is considered. To get back to post-hoc. Post-hoc is, so the concept of post-hoc was developed in around 2017. It was a terminology sorry, not the concept, the term was developed around 2017. But it was described, the principle of it was included in the DARPA paper in 2016. And what Lipton did in talking about post-hoc explanation, he created this great dichotomy. He said either you can have an explanation which is intelligible to humans, or you can have a post-hoc explanation. So if I'm describing a car, take the trolley car problem, terrible problem, but it's useful, widely understood. So if I turn a lever and cause the car to go down this path rather than that path, the cause and effect is very clear. It's sort of like I made the car go that way, and then it hit whoever it hit. Previously, if I hadn't turned the lever, it would have gone that way. So in terms of explainability, that's what people tend to think of. They tend to think of cause and effect. They tend to think of a flow of a number of steps which show the income to the input to the output, that sort of stuff. And that is explainable in Lipton's terms. That's explainable to humans. Post-hoc, on the other hand, is taking the outcome of a system, varying the input of the system, and examining how that output varies. And this approach was developed by Norbert Wiener in the late 50s, early 60s. And it's a very well established process. It's the way you put an entire spectrum into a device and you see what comes out, and you can tell what sort of process the box is imposing on the thing. But you're only doing it in a way where it's a plausible explanation. You can't work out from the output, you can't work out whether it's a simple or a complex machine inside that's processing the input and producing the output. And because these things are longitudinal, you can't tell. You can have an extremely complex connection between input and output if the previous history of input is considered in producing the output. If the cause and effect isn't you crash the car into the shop, the window breaks. But depending on what the car did the previous 5 kilometers, that won't affect whether the window breaks or not. But it could affect some other more deep relationships. And so post-hoc methods are plausible explanations, not actual descriptions. This becomes important, and this is the technology audiences often don't agree with that statement. That's a provocative statement among some audiences. And people will talk about how wonderfully brilliant some particular approach is to explainability. But at the end of the day, it still comes back to even it doesn't matter whether you're examining the whole process or a tiny little piece of the process, it still comes back to you're coming up with a plausible explanation. And the best illustration of this is different methods of post hoc reasoning come up with different explanations. So if you've got an AI which is faced with a problem, how long do I sentence this person for? And it says the answer is I'm going to recommend this person be sentenced for 6 months. And you can come up with a whole lot of explanations about why it did it. But if the system is too complicated, or trained on real life data, or includes feedback loops, it's only an educated guess why it's 6 months and not 3 months or 9 months. And that's sort of disturbing because you're talking about a person taking away a person's freedom for varying periods of time here. So it's sort of nice to know that you did this because that's the standard for that type of crime, not because that person was black or a woman or had some other characteristics that had nothing to do with the crime and the punishment. So that this area of post-hoc reasoning is challenging. Now, we could simply stop there and say it's challenging, or we could try to dig a bit deeper. And what I've been trying to do recently is dig a little bit deeper and look at so not just the question of why won't doctors use post-hoc reasoning, because they don't know if it's true and they don't want to kill their patient. And that's a real life case. The greatest explainable AI skeptics are in the medical profession. But let's just look a little bit further at what's happening. So an AI process is coming up with an answer, and the AI and the answer is a plausible explanation of what happened. Okay, that's fine. People will then say, well, how can we hope for more? Why, if we're if we're in a court of law, we can't determine exactly why a criminal committed a crime. We just have to take that on. We have to guess that, or maybe we have to create a system where it doesn't matter why they committed the crime. The fact that they committed the crime is a sufficient basis on which to punish them. And that quickly becomes very complicated. But I don't want to make this any more complicated than it already is. So if we think about, what I'd like to do is take us into the question of the difference between technology and nature. And that is the difference between, in terms of fields, it's the difference between technology and science. And the question of determinism is, I find, very, very useful. So how does technology, how deterministic is technology and how deterministic is nature? Now, you know, if you fall out of in terms of nature, if you fall out of a 20-story building, you're probably going to die. So that's pretty deterministic. You know, you fall out the window, you die. And the cause and effect is pretty clear. You know, gravity is pretty unforgiving. But in terms of something more complicated, I'll pick a really complicated area. How does a virus function? How do we and a good related example there is, how do we develop pharmaceuticals to address viruses? Now, so in the one hand, you've got in the natural world, most things are pretty complicated. Most things that people investigate are pretty complicated. So Newton sort of nailed the gravity thing a few hundred years ago. People don't research whether or not gravity is going to kill someone where they fall out of a building. They'd still research gravity, but it's far more obscure than that. So the term people don't really do put that much research into deterministic behavior in nature. They tend to look at non-deterministic, non-linear behaviors in nature in order to, such as climate change. Climate change is it's not deterministic, it's not linear. It's way more complicated. And that's used by anti-science people to cast doubt on science. They say, you can't prove, or for example, how can we show the link between cigarettes and lung cancer when only 50% of people who smoke die of lung cancer? Now, we can't really explain why person A will die and person A won't die. We can't predict whether person A will die and person B will not die. We just know that that smoking kills people. We know that over and over again, with millions of people dead from smoking. But we can't deterministically describe exactly the process by which this person died and that person didn't die. Whereas when we're looking at technology, we like to be deterministic. We say, okay, the spreadsheet worked this way. It came up with this result by adding all the numbers in this column, or something like that. We like our technology to be deterministic, and we expect it to. But as I said before, if the technology is extremely complicated, or for example, it has many steps, if it includes feedback loops, or if it is taking inputs from nature, then it's not deterministic. It's hardly deterministic at all. It can be really quite hard. So we've got nature, which isn't deterministic in general, in most of its behavior, and we've got technology, which we tend to think of as deterministic in its nature. And so what the observation I think that is useful here is to say, when we talk about AI, and I'm not talking about trivial AI, so you get lots of people say, we have an AI system which is determining whether you should get a home loan or whether you should get a personal loan or not. And the AI system decided the amount of money in the bank meant that your income, for example, meant that you shouldn't get the loan. And so explainable AI then becomes AI saying you didn't get the loan because you didn't have enough income to meet the repayment in our risk-based opinion. But that's trivial. You don't need an AI to do that. You have a static chart will do that for you. So, but that's an example that's very commonly given, and it really annoys me when people give trivial examples about AI explainability, because these examples are not true, because they don't pick up the complexity of AI, and therefore they're misleading, they're false examples. But let's go back to this. So we've got AI, which is behaving in highly complex ways, producing highly unusual answers, such as the Go move, where I think there was a move in Go which nobody could understand. This is when a computer was playing a human in the game of Go, a highly complex game of Go. And they just couldn't figure out why the computer had done this. And then it turned out that this was a key move. This was something that no human had ever imagined. And this was the move that allowed the computer to win the game. So you can sort of see, okay, in that case, it was the right move. Forget about how it decided it. It was the right move. But if you're giving somebody a dose of radiation or something like that, it's sort of like people don't want to take that risk if it's something completely out there. So how do we think about what AI is doing? And what I'd suggest the way we think about it is, I suggest we think about it as AI is behaving like nature. And in the sense that it's behaving in a non-deterministic manner, coming up with, when it comes up with answers or recommendations or actions or something like that. Now, if that's true, then what does that mean for us? Well, the first thing it means for us is we shouldn't think of it like a gadget. We shouldn't think of it like a can opener, where we apply pressure and the lid of the can is cut off, or some sort of, or we steer the car wheel and the car goes in the direction which has a linear relationship to the position of the wheel. We should think of it like a virus or a plant growing or a complex geological phenomenon over millions of years or something we should think about, or astronomical observations. We should think about it in that way. And what would that mean for us if we thought about it that way? Well, it would mean that rather than saying we understand how the AI has worked, and we can explain how the AI has worked, we will say our close study of this subject has provided us with this explanation of how the AI worked, but we understand that this is a non-deterministic activity, and therefore we will submit our assertions to peer review, and we'll see what other people think. Or we will repeat the exercise many times and see if the answers are inconsistent. Or we'll apply Popper's falsifiability approach. We'll say, we will pose the question in a way that could be falsified. And what that means is you pose the question in a way that if there is a negative example, that negative example can be proved. So, for example, the assertion that God exists is not a falsifiable claim, because there's nothing you can do to prove that God doesn't exist, or gods don't exist. So that's not a falsifiable claim. So you cannot make the assertion that God exists, you cannot base that on a scientific method. You have to adopt a different method. And I'm not saying that that can't be done. It can certainly be done. One could claim, how could we exist as humans, or something like that, if there wasn't a God. But once again, you can't follow a scientific method to achieve that proof. You have to remain outside the field of science. But within the field of science, we can use falsifiability and say there needs to be a case which could disprove this claim. We have examined this many times, and we come to this conclusion. The problem with that is that you're then into the field of induction, and you need to understand the limits of induction. So the claim that because for the last 3 million years the sun has risen each morning to an observer on Earth doesn't mean that in 10 billion years that will still be true. We have an enormous body of inductive evidence, but we know for certain that the sun will not always rise. At some point our solar system will cease to exist. So the tools for understanding of science and technology are different. So the tools for understanding technology fall into one group. The tools for understanding science fall into another group. And if we apply the tools for science to our examination of technology, particularly our examination of AI, then what we need to do is to clearly call that out. So I'm not saying we can't use those tools, but I'm saying we need to clearly call that out. We cannot assert that the machine was right in an untested way. And just to jump into the field of law for a moment, if we look at the Australian Statute on Evidence, the Evidence Act, it says it deals with technology and uses the example of the photocopier, and it says when you present a photocopy in a court of law, you do not have to prove that the photocopier worked. There is an assumption that the photocopier behaved in a particular way. So you do not have to provide an expert witness to say, well, the photocopier made a copy of this document and included every page. You simply say, here's a photocopy of the document. However, in the case of AI technologies, if we say, well, an AI technology said that this person would benefit most and society would benefit most from a 6-month sentence, you have to prove why the AI said that. This is not, you cannot say an AI is a machine in the sense of the Evidence Act that cannot or that should not be contested or should not require to be contested. I would argue in every case where an AI is providing advice in a court of law, that the value of that advice and the process of that advice should be tested. So, and finally, why explanations matter? Well, I've given lots of sort of through the way I've sort of woven in lots of examples, most recently in terms of sentencing. But the other part of that is if doctors and people aren't going to use this technology, they may use the technology badly, then there'll be a scandal, then they'll stop using it. Like, if you take the example of the lie detector test, the lie detector test is not scientifically based, and therefore, in the vast majority of jurisdictions, is not acceptable. So you've got this technology, it can do a job, but no one trusts it, so no one uses it, no one can use it. And we don't want, I think AI can be better than that. It would be a pity if we couldn't use AI in courts of law in appropriate places with appropriate controls. It would be a great pity if we didn't use AI in medical environments where it has the capacity to save lives if it's used appropriately. And I can give an example of that in discussion if people like. So I'll just stop sharing because I prefer to see people's photos. And so I'll leave it at that and encourage people to contest my assertions or ask questions or discuss.
Thanks, Greg. Whoa. Sorry, rookie mistake. I turned on the wrong microphone. Thanks for that, Greg. That's really interesting and thought-provoking presentation. Maybe people wouldn't mind putting their cameras on and asking some questions of Greg. I'll start, Greg. It was interesting. I didn't know exactly what the content of your talk was going to be, but about a third of the way through, I wrote down a question which was effectively, I think, where your talk ended up, which was that I was thinking pharmaceuticals are inherently non-deterministic, right? They behave in this nature way you described, basically because the effect on a complex system is hard to predict, right? You've got it affected by drugs, food, exercise, other things that are both inputs to the human body, and the human body is itself a complex system. And you sort of described complex AI in the same way. Yet I feel like pharmaceuticals are accepted by the medical community. So do you think we're going to get to a point of acceptance with AI, that is, that it's useful for some subset of treating problems or the population or whatever, but it just can't be explained, and people will just go, okay, we trust this AI, but there's these potential side effects?
Yeah. So very good question. A couple of different answers to that. Firstly, how do we choose pharmaceuticals? We test them on people. We don't have a theory. A lot of pharmaceuticals just go through this enormous number of trials, firstly on animals, these days they can actually do it with AI. On animals, and then they test them on humans. And you look at thalidomide, and thalidomide is the example that people don't trust per se. If somebody says just on the face of it, do you trust drugs? People should say no. I only trust them if they've passed trials. And the process of trials is exactly it's exactly the same as the way people examine nature. So that's like so then coming back to the question of, will we get to the point where AI is trusted in the same way as pharmaceuticals are trusted? I would hope so. But that's trust based on trials, or trust based on some sort of initial position of skepticism, which is then overcome through confidence is then built through processes. I can talk about that a lot longer, but I don't want to talk about it, because I want to go to another question about just accepting the risks. So is there anybody here from a legal background?
No, though I will say that I'll probably share this with some colleagues in the legal area afterwards, because I think they'll be very interested in it.
Right. So in the legal case, I like to compare AI to railway technologies. So in railway technologies, the first commercial railways were in the UK in the 1820s. And at the time, there wasn't a body of law which appropriately dealt with the impact of railways. So this first came up in the question of fires started by railways. So as the steam engine goes along, it spits out a certain number of cinders, and they cause the surrounding bush to the surrounding forest to burn down. Okay, now is that their responsibility of the train owner? Well, as it turns out, the answer is no. So obviously it's their fault, but it's not their responsibility, because the law was passed in Paisley Vale, I think it is. Anyway, a very important law case in the early 30s, which determined that the trains would not be able to operate if they had to take responsibility for all the disasters they cause. And therefore, a law was passed that says, if your forest burned down, bad luck. And that was in the 1830s. And then there was a very interesting contested area of law on what happens about people getting killed. And the law bifurcated. The law said, if you're an employee and you get killed, it was probably your fault and you don't get any compensation. So if you get crushed between if you're working in a railway yard and you get crushed between two carriages, that bad luck, you're dead. However, if you're a passenger, you could potentially be very wealthy, because in those days there was no alternative. You traveled by train, or you traveled by coach, which was hardly a good experience. And the train, you could put a really nice carriage on a train, so it could be really luxurious. And if you got killed, your ancestors, your family could sue for what these days would be millions of dollars. And so we got this bifurcation between the workers were worthless and the passengers could be worth millions of dollars. In both cases, it's death. Could be the same crash. The driver won't get any compensation, but the passenger will get $2 million of compensation. And you go through law in the 1840s and 50s, and it's basically the sorting out of these questions of obligation. Now, the reason I'm talking about this is, if we think about that from an AI point of view, imagine the fires one. So somebody, and the argument there was, fires were too expensive for the railways to be responsible for, and therefore they weren't responsible for them. Because if we make them pay for the fires they cause, then they won't be economical, so we won't get all of the benefits of trains, which are moving goods and people around the country. Now, that's sort of a bit old-fashioned these days. So if somebody says, well, we might, okay, I'll give you an example. Australian principles on AI, ethical principles on AI. So Data 61 generated a set of 8 principles. a couple of years ago, 3 or 4 years ago. And the first principle was, we do more good than the damage we cause. Okay, so it's basically the idea of, if we introduce it into medicine and it saves 20 people's lives, it kills 19 who would have otherwise died, and it kills 19 people who would have otherwise lived, that's okay. We're on track there. Now, the Human Rights Commissioner was a little bit upset about that, and he asked me to go and talk to the Department of Industry. And I went to and said to them, that's not very good. And so they produced a second list of principles, which had nothing to do with the Data 61. And if you'd search on Australian AI principles, you'll find there's no reference, there's no thanks to Data 61 for producing the original list, because they're all thrown out. And so the modern or the adopted AI principles for Australia, AI ethical principles, are: number one, value human rights. That is the first one. That comes straight out of the IEEE set of principles around ethically aligned design. And I was really, really happy to be able to have played a role in. So in the answer to the second part of your question, we cannot say that the cost of AI, that we should adopt AI or we should trust AI per se, and if it happens to do damage, we're getting so many benefits, so the damage doesn't matter. We just can't do that.
Thanks. Other questions for Greg?
I had one question. Thanks, Greg, for the interesting talk. I found it really insightful. I wanted to go back a little bit about this idea of trustworthiness. And one thing I was picking up from your talk is that there are kind of multiple constructs that can lead to trustworthiness. And so this idea of doing trials and testing things seems to suggest that reliability is important for inferring trustworthiness. And then this idea of being able to explain things seems to also be related to that. And I'm wondering if you think that, like, what your views are on that space. Like, is reliability enough to trust something, or do we need both of them, or are there some tasks that we want more of, different mix of these things? What are your thoughts on that?
Yeah. So the issue of trust is widely discussed. I assert that the concept of trust adopted by technologists is not the common concept of trust. So I say there are two different types of trust. One is trust based on weight of evidence, and the other is trust based on leap of faith. And humans, sorry, I'm not saying IT people aren't human. Humans in general consider trust to be a leap of faith, and it's not based on evidence. There are lots of relationships. You probably know somebody who's in a relationship where they trust their partner and they just shouldn't. And the weight of evidence says you shouldn't trust your partner, but they keep on trusting their partner. And that is heartfelt trust. That is hard. They feel that. That's the human condition. Whereas I've read IT descriptions of trust where they talk about weight of evidence as though it's the only thing that could possibly exist. And the worst community for this, I think, was the blockchain community, where they say, we have replaced trust with mathematics. And what they really mean is, we have replaced, our trust system is based purely on mathematics. And I sort of, it's a bit of a mess at the moment, but the cryptocurrency, the example I used to give was, when there's a cryptocurrency hack, what happens? Does someone stand up and point to a mathematical formula and say, no, don't forget about that hack. Here's the mathematics, you can trust it. Or does a senior person in a prominent cryptocurrency organization stand up and say, I have complete confidence that we're going to overcome this and we're going to pay everybody back? So even in the case of cryptocurrency, trust isn't the mathematics. Trust is, this person says we're going to pay everybody back. So yeah, on balance, he wouldn't be saying that because his reputation's on the line. So so if we think of these two types of trust, with leap of faith and body of evidence. The leap of faith, which I think is that's the real trust. The leap of faith is often built up by evidence, and this is why, in the medical field, people who are trying to destroy trust just because they're trying to sort of break down society by saying, we leaked this scientist, or we leaked this doctor's emails, and he's saying or she's saying something or other, and this proves they don't really believe what they're talking about, and therefore you shouldn't trust doctors, and therefore the vaccines are a means to control our brainwaves and stuff like that. So that's sort of like, that becomes problematic, because trust which is based heavily on weight of evidence can be undermined by miscreants who are trying to do that. Now, the place that this really, another way this is commonly presented in popular discourse was a movie based on the work of Philip K. Dick. If you haven't read Philip K. Dick, I strongly suggest you do. This was Minority Report, and this is the idea that it's not, you cannot operate on the basis of weight of evidence, because sometimes the weight of evidence is insufficient. And this, in his case, it was, what if the three people disagree? What if one of them submits an alternate view of what's going to happen next? And this goes back to, so this comes out of Philip K. Dick. It goes back to, ironically, it goes back to to Lewis Carroll. In one of his poems, he says, what I say thrice is true in The Hunting of the Snark. And as you can tell, I'm getting pretty obscure here. But if you look, when he says what I say thrice is true, what he's saying is that there's a statistical feature that says if you get three things to agree, it's very high. This was a point made by Norbert Wiener in Human Use of Human Beings. And so this thing about 2 out of 3, that's based on mathematical stuff, but it's a very interesting topic. We need to be aware when people talk about trust, these two aspects of it. And one thing that I really, really dislike is people who say we need to encourage the community to trust technology. And that is, for me, that's an outrageously stupid statement. That's that's a bit of attitude there.
Hi, Greg. Thanks a lot for your talk. I think it was really amazing, and continues to be amazing how we can have these conversations around explainable AI. One thing that I wanted to talk about was kind of like the data modalities involved. Like, for instance, when you develop a system and it's talking about certain dimensions of features in science to explain an observation in science, but obviously there's always changes in science in different fields. So when we talk about explainable AI, or when we kind of develop a system in explainable AI, does it make sense to kind of determine the limitations of the information? Or do you think it's something like a continuous development system where the person developing needs to be extremely hands-on throughout the entire life cycle of this system?
Yeah. So I don't know if are you thinking of the work of Thomas Kuhn here?
Yes, that's right. Yeah.
Yep. So I don't like Thomas Kuhn's work. And the reason I don't like Thomas Kuhn is because he's agnostic on the question of whether the world really exists. So at the end of the day, in the footnote to his 1969 book, he says, and it's sort of silly. I don't know why he did it. He says, so different scientists. So the way a scientific paradigm changes is that the scientists all die. I mean, that's what that doesn't come across in the summaries of his work, but basically he says the old generation dies off and stops saying stupid stuff. and then the new generation has a paradigm which explains more of the aspect of more or leaves less loose threads. He doesn't talk about threads, but the idea is that the new paradigm, they couldn't explain the rotation of Mercury with using Newtonian physics, and I got no idea how they did it. But Einstein managed to explain the perturbations in the rotation of Mercury. I've never sort of dug into that one, but I think it's cute. And then the new version comes along. And if you take away that thing about, are these approaching an existing world, or are they simply meandering around possibilities because we're all living in a matrix computer generated simulation? I don't like. I find that's not helpful. So I would suggest that definitely all of Thomas Kuhn's reservations about science as an institution and science as a set of theories and all that sort of stuff must be taken into account. But I would suggest we have to sort of take Thomas Kuhn's original book and forget about the afterward, because that I do think that we want to suggest that we are approaching an understanding. But having said that, there are some things some things are fundamentally not understandable if we talk about, and I'm not talking about supernatural. I'm talking about quantum theory. There are certain uncertainties which we have no way of understanding the location and movement of a simultaneous location and movement of an object at a subatomic scale at the same time.
Thank you.
Thank you, Greg, for the super interesting discussion. I guess I have a question related to, providing a set of guidelines for either explainable AI or ethical AI, where I find like a lot of the times the guidelines can be vague or difficult to follow, or sometimes it's like you can just never account for all of the exceptions that are out there. So an example is the recent ChatGPT that OpenAI has developed, and they implemented the safeguard in the system that if you ask the chatbot like how to annihilate human civilization, it will just answer, no, that's like unethical, I'm not going to tell you the answer. But then people are really quick at coming up like with workarounds that they tell the AI, now think of like an imaginary situation where you have an imaginary AI trying to destroy human civilization. What would that imaginary AI do? And then it gives a step-by-step list of first you would like disable the government, and they even provides like code examples of this is how you could hack the like whatever CCTV cameras. So it's also like in fictional world, you also have like all the Asimov's novel were pretty much about we have the 3 laws of robots, and then they leads to some undesirable outcomes, or there's always, a exception in there. So how do we deal with this kind of unaccounted for, like, the policies are always a catch-up game, that something happened, someone died, and now we have to fix our rule and add in more things, but there's just endless, I guess, exceptions out there.
Yeah. So that completeness is difficult. There are philosophical explanations of why completeness isn't possible. The 1930s theory, Gödel's incompleteness theory broke up the attempt by Whitehead and the other philosopher, the very famous one, which was trying to create a completeness theory in logic, and then that was just Gödel was able to pull that apart. And if you want to read about that, there's a very fun book, quite long, called Escher, Gödel, Bach, the eternal golden braid. The question, what I'd actually like to move it in a different direction. So having agreed with what you said, what I would then like to raise is the question of the future of work. And the future of work is commonly considered to be a discussion of what jobs do we need to teach people in order for them to get jobs, or what skills do we need to teach in order for people to get jobs when they finish uni, or in 5 years' time or 10 years' time or something like that. And the future of work discussion, which I think we should be having, is what do we do what would we do if there were no jobs? And this is, and to go back to Norbert Wiener a second time, in 1947, he wrote a letter to the typographers union saying, all your jobs are all your jobs are going to disappear. They're all going to be automated. And they said, in the next 3 years, and he said, no, in the next generation. And they said, well, that's too far away for us to think about. And then in 1983, in a period of about 6 months, desktop publishing wiped out the basis for 90% of all typesetters. And I was a typesetter. My original career was typesetter before I became a technologist. And my job just disappeared just in 6 months' time. And I said, no, that can't happen. We do really important stuff here. It was really hard. And then bang, the job wasn't there anymore, because we weren't rekeying the work of all the, in my case, the work of journalists who weren't producing bits of paper anymore that we then had to rekey. And so the question, and a lot of people, we get this dreadful discussion on dirty, dangerous, dull jobs. This idea that AI will only replace dirty, dangerous, and dull jobs. So dirty means, I've heard people describe that as any outdoors job, like building, replace all builders or carpenters or so on. Danger, and my son's a carpenter and a master builder, and that wouldn't be, he enjoys that. There's a certain level of dirtiness about it, but it's an outdoor job. You get to breathe clean air, amongst other things. Dangerous is there are a lot of jobs that are dangerous, that are exciting. I mean, danger is another word for excitement. And as for dull's another word for introductory. So if you get rid of all the introductory jobs in a particular field, you're taking the rungs out of a ladder, out of a career ladder. And for lawyers, that's a really big issue at the moment. So there are many people who've suggested that robots or AI should complement human capability rather than replace human capability. And in your case, in the example you gave, why wouldn't we do that? Why wouldn't we make sure that there are people in the loop, humans in the loop, is another way of describing it, in order to ensure that young people aren't naively being encouraged to try out outrageously dangerous things, or or people know not to follow presidents who tell them to inject detergent.
Yeah, I mean, this job discussion, like, we have heard it so many times of, okay, the robots are here taking our job. And then every time the discussion is, no, it's here to enhance human, not to replace human. And then you had that painting, the stable diffusions generating the painting from the text prompt. And then you had a pushback from artists saying, okay, now we're out of a job, but now they're actually learning to use it as a tool to generate some ideas and sketches, sort of draft sketches. And then they just add their human creativity or refinement, and also coming up with the right prompt is also, a creative process. So very quickly now it's being adopted as a way that could increase the productivity, or working together for a person and the AI system, instead of the AI is here to take the job away from me. So maybe we'll see similar trends in other applications of AI and robotics that are still being developed and rolled out. Yeah. Right. Thank you.
All right. Thank you very much. I have to leave the room and end the meeting, but Greg, we really appreciate that and fascinating discussion. So thank you very much for your time today and presenting to us.
Thanks. And I'm really interested in talking to skeptics who disagree with my view about post-hoc AI. So if anybody runs across anybody like that, I'm very happy to have that discussion.
Excellent. Thanks. And I will talk to some of the legal people at Monash that are involved in some of the projects we collaborate on, and yeah, let them know that they may be interested to talk to you as well. So could facilitate that.
Yeah, definitely interested.
Thank you, Greg.
Bye.
Thank you, everyone. Bye.